Hello everyone, welcome to this class. We're going to deal with anti-logarithm, or you can call it inverse logarithm. In our previous class, this is what we did. We first introduced logarithm through indices, and we are now telling you that the logarithm of 100 in base 10 is 2. So what we are doing in this class is trying to find the anti-logarithm, that's reversing these two. What will be the anti-logarithm of 2 in base 10? So we are trying to say, okay, bring these 2 back to 100. In this case, logarithm of 32 in base 2 is 5. We are trying to bring this 5 back to 32. It's like saying 10 raised to power 2 will give us what? Or what is like when you find the logarithm of x in base 10 and it gives you 2, we are trying to find what that x is that gave rise to the 2. So what I'll do basically in this class is all these questions that we solved. See how where we started solving. I'll find the anti-logarithm to prove that what we are getting back the real answer we look for the log in the first place. So we are still going to deal with our statistics. We use our statistics table, our characteristics, our mantissa, and our main difference. So the first one we deal with is 37, and we got 5682. So that will be my first example I will solve. This is anti-logarithm. The logarithm of 2 in base 32 is 5, and the logarithm of 1000 in base 10 is 3. So first example I'm going to solve is the example we did in the class where we have 37. Let's say example 1. We found the logarithm of 37, and we're able to get from our last class that logarithm of 37 is what? See the answer, 0.5682. Mind you, we'll look for the logarithm of 37, 3.7, 37, and 3700. That's 3700. So the most important is that the mantissa is 5682. So let's look for the anti-logarithm. So we have 37. We also have 3.7. We also have 3700. And here I got from our answer 5682. Here I got 3.5682. Hope you can see this. And here I got 1.5682. So now let's start solving. When you are solving for anti-logarithm, mind you are taking inverse of the logarithm. You are going to ignore all these characteristics and solve for the mantissa. Ignore the characteristics. Ignore the characteristics. I will tell you what role the characteristics will play in the answer. So here I'm going to only focus on 0.5682. So I'm solving for the first one. I'll go to my table. This is the table we are using. Remember what I said in the previous class is also at the back of your textbook. I'll go to the anti-logarithm. Here is the logarithm part. So I'll go to the anti-logarithm. As you can see, it comes with .30 ... meaning that they are ignoring the characteristics part and dealing only with the mantissa. So here I have 56. So I'll look for 0.56. This is 0.56 here. Order what? 8. I'll look for my order 8. This is my order 8. So 0.56 order 8 is 3698. So I'll write it out. 3698. Now difference of 2. Difference of 2. The mean difference is 2. 0.56. I'll go to the difference of 2. This is 2 difference. Is what? 2. So I'll add 2 here. So when I add this thing up, this will give me 0.073. So this is my answer. Are we together? Still the same way we deal with logarithm. Look for the first 2 digits, but in this case, just that you are not only focusing on the mantissa, you don't have any business with characteristics. Get these first 2, the order and the difference. So when you've gotten this, mind you, what we have here in the mantissa is also what we have here in the mantissa is also what we have here in the mantissa. So indirectly, this is the answer to these 3 questions. Now, how do we now distinguish them? That's where the mantissa, that's where the characteristics play the role. This is where the characteristics plays the role. Sure, get here the characteristics is 1. So for the first one, this 37 will be, because the characteristics is 1, it means that the characteristics is what determine where the dot will be. So for this to be 1, it will be 37. That's the number 1. Because if you change this to standard form, you will get 3.7 times 10 raised to the power 1. I don't know if we are getting it. So one of the best way you can go about it is write this as a standard form, the answer you are getting. For the first one, you can say put a dot here and multiply 10 by whatever the mantissa is. That's your answer. Let's say for the first case, we have something like 3.7 times 10 raised to the power 1. So when you open up this, you are getting 37. For the second one, number 2, this is what we'll get. So you can say 3.7 times 10 raised to the power 0. When you open up the bracket, you still have your 3.7. This is the answer for the second one. This is the answer for the first one. For the third one, you can say 3.7 times 10 raised to the power. Mind you, the mantissa is what I'm giving the power of 10. Here the mantissa is 3. I'll give it to the power of 3. 10. That is, when you open it up, it will be 3,700. So you can see that we have gotten, this is what we look for the anti-log, and we've gotten the answers as is in the previous class. So let me pick other examples to solve in the previous class again and look for the anti-logarithm. This is example 10 we solved in the previous class, 37.4 and 3.746. And these are the answers we got. So let me write it out and solve for it too. So this is the logarithm we look for in the previous class, and we got this as the answer. We look for this and we got that. So I'll pick my anti-logarithm table. Remember what I told you, don't have any business with the characteristics. So this is the number we are looking for the anti-logarithm to know if we are getting this back. So let me say number 1, we have 1.5726. So what I'm looking for actually is the mantissa, 5726. Remember, you just look for the mantissa. The characteristic is for you to know where you place your decimal point after you finally get your answer. So bringing my table, 57, I'll look for 57. Order what? Order 2, difference 6. So this is my 57, order 2. It will be 3724. Let me write it out. 3724. Difference of 6. I'll look for go to my difference side. 6 is what? 5. So I'll add 5 to this. I'll get 9, 2, 7, and 3. Are we together? So this is my mantissa. This is my answer. Remember what I told you, how you can finally make use of the mantissa. The mantissa here is, the characteristic here is 1. So just assume this is 3.729 times 10 raised to the power what? 1. I told you the best way to get it is assume when you get your answer, put dot, put it in standard form, put dot after the first digit and multiply it by the mantissa, 10 raised to the power the mantissa. You get your real answer. This is actually like the way you be taught in the textbook, or this is like my own way of making it. I think this is the easiest way you can get it, so that you don't get confused with mantissa. Some people get the answer and they will now misplace, sorry, they will not put the wrong, they put the decimal point in the wrong place and end up failing the whole question. So this will give you, let me say 37.29. Now if you put this in, let me say you approximate this, you get something like 37.3. That's if you do one decimal place, right? You can see that the answer is close. Mind you, we are dealing with decimals, so we must not get exactly the same answer. You can still get something that is close. So you can say that this is 37.4, this is 37.3, it's still close. Let's solve for the second one. 0.5736. So let me say number 2, 0.5736. So I will deal with the mantissa, which is 0.5736. So I'll look for 57 order 3. This is 57. Order 3, 3741. So I'll write it out. 3741. Difference of 6. Difference of 6. This difference of 6, 5. So I'm adding 5 to it. Are we together? So when you add 5, you have 3745. So the next thing we are going to do is we just do what I told you. Just do it 3.745 times 10 raised to power 0, because the mantissa here, the characteristics here is 0, which should still give you 3.745 as your answer. So you can see that we found the anti-logarithm of this number and we'll get the logarithm that we have in our previous class. It's just the only difference that here we have 3.745, but here we have 3.746, so it's still close. Some cases you don't need to get exact number, as you know in this first example we got the exact number. Just know we're dealing with little decimal numbers, so there will be some little variation in them. So let me solve the last question we did in our previous class. I think this is the last question we did, these 3 questions. So I'll write them out. So this is what we did in our previous class. I decided to choose only one because all of them have one characteristics. So I now brought exercise 1I where we have different characteristics. So by so doing, we can learn how to place these characteristics in it. So here now we are looking for antilog of 0.5725. So the first example, 0.5725. Now the characteristic is 0. So but this is what we are looking at for. I'll go to 57 order 2. This is 57. This is order 2 here. 3733. So I'll write it 3733. So the difference is 5. So this is 57. I'll go to difference of 5, which is 4. So I'll add 4 here. So it will be 3737. So this is my answer. So the next thing I will do is take care of the characteristics. Remember what I told you? Just say this is 3.737 times 10 raised to power what? 0. Remember what I told you? When you get the answer of the anti-logarithm, put the decimal point after the first digit and multiply it by the 10 raised to power the mantissa. Whatever the answer gives you is your anti-logarithm, please. This is the easiest way I think you can solve this characteristics problem, because some people get the correct answer as I repeated before and make mistake with adding the decimal point in the right place. So the answer will give you 3.737, which is exactly what we solved for. You see, in this case the answer is exactly the same. So sometimes when you have these little changes, if you see in the previous class I mistakenly said that one is wrong whereas it's correct because of just 0.0001 difference. So let's take note of that. Now let's solve for this and that. Now let me say this is exercise 1I, the B part of it says 4.9517. So you leave the characteristics, you just focus on 9517, which is the mantissa. So this is 95, order 1. We'll go to 95. This is our 95 here. Order 1. This is our order 1. 8933, which is 8933. Difference of what? 7. 95, order 1. Difference of 7. Go to your difference. 7. Go to your difference. 14. 14. If you go up, you see that this is 7. 14. Just to make sure that I'm not making mistake. This is 5. I go straight. 14. So I'll add 14 here. I'll have 7, 4, 9, 8. So this is my answer. To get the correct answer, I will simply do 8.947 times 10 raised to power what? The characteristics. So this will give me my final answer as 8, 1, 2, 3, 4, 9, 4, 7, 0. This is my final answer. You can always confirm this from your answered part of the exercise. So the number 1A, you have 3.6382. So this is the characteristics. Focus on the mantissa, which is 0.6382. So 63, order 8. Go to 63. This is 63 here. Go to order 8, which is 8. 4, 3, 4, 5. 4, 3, 4, 5. Difference of 2. 63. Difference of 2, which is also 2. Just add 2. You have 4, 3, 4, 7. Now we bring in the characteristics. It will be 4.347 times 10 raised to power what? The characteristics. We should give you 1, 2, 3. Answer will now be 4347. This is your answer. So that's it about antilogarithm. Once you understand logarithm, the antilogarithm is very simple. Just when you are given a number to find the antilogarithm, don't include the characteristics in what you are going to look for in your formula table. Just go straight to the mantissa. The first two, now use the same formula we use when we are solving for logarithm. Find the first 2 digits. The third one is the order, and the fourth one is the difference. Just add the main difference to it. And whenever you finally get your answer, you now consider your characteristics. How do you get your characteristics? Whatever you get as your answer, let's say in this case, we got 8947. Bring it out as 8.947 times 10 raised to power, whatever the characteristics is. Whatever it gives you is your final answer. Thank you, and see you in the next class.